Hello, and welcome to my channel. I am Thomas, and I do videos on educational matters. Uh, Today is video number 199 on the reciprocal system of theory, which is authored by Dewey B. Larson. He wrote a number of books and a lot of articles on the reciprocal system. It is a system of theory, which means if you understand the basic logic of it, you can apply it to any subject. It is a theory of everything, and you can use it for every subject. Larson wrote about physics, atomic physics, astrophysics, chemistry, astronomy, metaphysics, including religion and philosophy, and he also wrote about a little bit about dream interpretation, economics, psychology, and other subjects. Some of his followers have extended that to anthropology, geochronology, crypto, archaeology, and other topics as well. So it's been very fruitful over the maybe last 60 years of the reciprocal system. And we are looking at his 1979 book right now called Nothing But Motion, which is on atomic physics. The basic idea of the reciprocal system is that it posits a universe of motion. The universe is not made out of energy, not made out of matter, it's made out of motion. Energy and matter are merely two different kinds of motion, two different varieties of motion, both of, as is every other scientific dynamic or mechanical phenomena, such as speed, acceleration, force, electrical capacitance, viscosity and fluidity, electric charge, electric current, magnetic flux, and many others, pressure, density. They are all motions. And for Larson, motion is the relationship between space and time. So these all can be represented strictly as a relationship between space and time. For example, matter is time to the third power over space to the third power. Energy is time over space. Speed, we know, is space over time. And so time and space are in a generalized reciprocal relationship. In a fraction, the numerator is either time or space, and the denominator is either space or time. And they can be coordinate, meaning in 3 dimensions or more, just like coordinate space, XYZ coordinates. Time also has its coordinate aspect, which is not the same. It's not in space, so it doesn't have a direction in space. Its direction is in time. And then the clock aspect, clock time. Time is always getting later and later and later. Larson calls this a scalar motion. It's a motion that has a magnitude, but it has no direction. And there is also such a thing as clock space. That means that space is always getting farther and farther and farther apart. And you envision that by taking a balloon and a magic marker, putting dots on the balloon, you blow up the balloon, all the dots are moving away from each other. Suck in the balloon, all the dots are moving toward each other, but in no particular direction. It is a scalar motion. It has no direction, no particular direction. It has a magnitude. And then space and time also come at only discrete units. They are coming in chunks, not continuously. And exactly 1 unit of space in 1 unit of time is the speed of light. So the speed of light is really set up as the midpoint of this universe. So normally when we think in legacy terms, legacy science terms, we think of a 0, and then there's plus 0, and then there's minus 0. But in the reciprocal system, we use more of a multiplicative system where 1 is at the center, not 0. And by using multiplication, you go 1, and then up from 1 is 2, and down from 1 is 1/2. So then go up again to get to 3, down would be to get to 1/3. So it's not an additive inverse relationship like you would have if you set the midpoint at 0. In this case, the midpoint is at 1. And that is the speed of light. So the speed of light is really the midpoint of the universe, or the null point, or the origin, or the ether of the universe. And then there is a sector of the universe that Larson calls the cosmic sector that's actually moving faster than the speed of light. And then there's a sector that Larson calls the material sector that is moving slower than the speed of light. The material sector is what we're accustomed to. That's where we live. That's where we observe. But we also live in the cosmic sector in our minds. And the cosmic sector, is three-dimensional time and clock space. And we don't know really anything about the material sector in the way that we observe the cosmic. We don't know anything about the cosmic sector the way that we observe the material sector, but because of the reciprocal relationship between space and time and between the material and cosmic sectors, we can extrapolate what's going on in the cosmic sector from what we know about what's going on in the material sector. So, for example, we know in the material sector there are such a thing as atoms. Maybe we don't know that. We've observed these things, and we call them atoms. Chemistry, oxygen and hydrogen and carbon, and all 92 plus atoms. And we can deduce there that there's also going to be such a thing as cosmic atoms. And so a cosmic atom is just the same as an atom, but it's with time and space reversed. And there are certain differences in the way that we observe them, because in general we do not see time, we only see space. And so the only way we see time is how it affects space, and it affects space in an inverse manner. So that alters the measurements that we might make about a cosmic element or a cosmic atom, because we see it as an inverse quantity in space. But we also don't see the whole thing, because when you're looking across a boundary like that, you're only seeing kind of like the surface of what's going on there. So you have to, there's a reduction in the information that you're getting, and that has to be accounted for also. Okay, now we are reading Larson's book, Nothing But Motion. This is basically on atomic physics, and we are actually talking about cosmic elements. This chapter is called Cosmic Elements, or possibly Cosmic Atoms. And he's kind of determined here that the cosmic atoms are what legacy science calls the cosmic rays. And he had a few different critiques about, they look at the mesons as being material atoms, and Larson is saying that they are cosmic atoms. Okay, so let's let Larson talk here. The basic questions, what are the cosmic rays and where do they come from, are answered automatically by the theoretical discovery of a sector of the universe in which objects with the observed properties of the cosmic rays are indigenous. The particular properties that characterize the constituents of the cosmic rays and distinguish them from the constituents of aggregates of ordinary matter are naturally the ones that are the most difficult to explain on the basis of current theories, which try to fit them into the material system of phenomena. But these explanations are practically obvious once the existence of the cosmic sector is recognized. The energy questions are the central problems. As stated by Swan, no piece of matter can, under ordinary circumstances, contain in any form enough energy to provide cosmic ray energies for its particles. End quote. But this is only one phase of the energy problem. The total energy involved is also far too large. If cosmic rays move in straight lines, as does starlight, and have the same energy density as starlight, then the power supplies to each will have to be the same. There seems no conceivable way to find this much energy for cosmic radiation. And that was a quote from Leverett Davis. Here again, we meet the "there is no other way" contention that is being used to justify so many of the otherwise untenable theories and assertions of present-day science. And again, the development of the reciprocal system demonstrates that there is a conceivable way. But because the cosmic ray physicists have been confined within the limited horizons of conventional basic ideas, they have not been able to account for the observed energies on any straightforward basis. They have therefore been forced to invent exotic hypothetical mechanisms for acceleration of the cosmic rays from the relatively low energies that are available in the material sector to the high levels that are actually observed, and equally far-fetched storage processes to avoid the difficulties cited by Davis. The existence of another half of the universe, in which the prevailing speeds are greater than the speed of light, and the energies of the mass units are correspondingly great, disposes of both aspects of the energy issue. There are observable explosion processes in the material sector that result in the acceleration of large quantities of matter to speeds in excess of the speed of light, therefore across the boundary from the material to the cosmic sector. The most energetic portions of these high-speed explosions are ejected into the cosmic sector, the sector of motion in time. From the general reciprocal relation between space and time, we can deduce that these same processes are operative in the cosmic sector and that they result in the ejection of large quantities of cosmic matter into the material sector. This is the matter that we observe in the form of cosmic rays. So the cosmic rays are cosmic matter that are crossing into the material sector as a result of powerful explosions that accelerate these cosmic atoms. I would guess it would be they get accelerated in time to cross the speed of light, but I suppose that we would see that as being decelerating in space. We'll see what Larson has to say. The characteristics of these interchange processes, as they will be developed in Volume 2, explain why the distribution of the elements in the cosmic rays differs from the estimated average distribution in the observed physical universe. It will be shown that the proportion of heavier elements in matter increases with the age of the matter, and it will be further shown that the matter ejected from one sector of the universe into the other consists principally of the oldest or most advanced matter in the originating sector. Thus, the cosmic rays are not representative of cosmic matter in general. They are representative of the cosmic matter that corresponds to the oldest matter in the material sector. The isotropic distribution of the incoming rays is likewise a necessary result of entry from the region of motion in time. Both the spatial location of entry and the direction of motion of the particle after entry are determined by chance, as the contact of the space and time motions is purely scalar. So there is no specific direction. So they are determined by chance. The identification of the cosmic rays as atoms of the material of the cosmic elements was clear from the beginning of the development of the reciprocal system. As stated earlier, the available evidence indicates that these so-called rays must be atoms. On the other hand, their observed properties are quite different from those of the atoms of ordinary matter. The natural conclusion from these facts would be that the atoms of the cosmic rays are atoms of some different kind. Conventional science cannot accept this answer because it has no place for the kind of an atom that is indicated. The physicists have therefore been forced to conclude that the cosmic rays are ordinary atoms that for some unknown reason have unusual properties. In contrast, the basic postulates of the reciprocal system require the existence of a type of atom, the inverse of the material atom, that has just the kind of characteristics when observed in the material sector that are found in the cosmic rays. It should be noted in this connection that the concept of antimatter, the conventional alternative to the reciprocal matter required by the postulates of the reciprocal system, cannot be applied to the cosmic rays because the interaction of matter and antimatter is theoretically supposed to result in annihilation of both substances, rather than the particle production and other phenomena that are actually observed in the cosmic ray interactions. Although only a limited amount of time could be allotted to the cosmic rays in the early stages of the development of the reciprocal system, because of the large number of physical areas that had to be given some study in order to confirm the status of the theory as one of general application, the first edition did include an account of the nature and the origin of the primary rays, an explanation of the kind of modifications that these particles must undergo in the material environment, and a general description of this modification or decay process. In the meantime, there has been substantial progress both experimentally and theoretically, and it is now possible to expand the previous presentation very materially. The extension of theory in the cosmic ray area that has taken place in the 20 years since the publication of the first edition provides a good illustration of what is involved in the development of the theoretical system of the fundamental postulates. The basic facts, the identity of the cosmic rays, their place of origin, the reason for their enormous energies, etc., were almost self-evident once the reciprocal relation between space and time was recognized. But it cannot be expected that such an understanding of the basic facts will immediately clear up the entire multitude of questions that arise in the course of developing the details of the theoretical structure. The answers to these questions are available. They can be derived from the fundamentals of the system of theory, but they do not emerge automatically. Where a theory is developed entirely by deduction from a single set of premises, as is true of the reciprocal system, there should not be many cases in which wrong answers are reached, if the theoretical foundations are solid and due care is exercised in the logical development. Only a few of the conclusions stated in the first edition of this work have been invalidated by the 20 years of additional study that have followed. But it is altogether unrealistic to expect that the first exploration of a physical field by means of a totally new method of approach will accurately identify all of the significant features of the phenomena in that field. It is a virtual certainty that many of the original conclusions will be incomplete. Here again, the reciprocal system is no exception. The explanation of the cosmic ray decay that will be given in the next chapter is, in all essential respects, the same explanation that was presented in the first edition. However, the development of the theoretical structure in the intervening years has brought to light many necessary consequences of the postulates of the reciprocal system that have a significant bearing on the decay process and contribute to a more complete understanding of the decay events. These new items of information include such things as the existence of a transition zone, the two-dimensional nature of the motion in that zone, the existence of the massless form of the neutron, and the nature of the limitation on the lifetimes of the cosmic particles. With the benefit of all of this additional theoretical knowledge and a substantial increase in the amount of available empirical information, it will be possible to define the decay sequence more accurately. Nevertheless, the presentation in Chapter 15 is not a new explanation of the phenomenon. It is the same explanation in more complete form. Okay, now that is the end of Chapter 14, Cosmic Atoms, and so Chapter 15 is called Cosmic Ray Decay. So this is going to be about, now when the cosmic atoms, so when a cosmic star blows up and sends its particles across the speed of light, entering into the material sector, we observe this as it enters the material sector, but because it is from the cosmic sector, it immediately is unstable. It decays immediately because it's in a foreign environment, and so there's only certain aspects of that cosmic atom that are able to be stable in this environment. So it immediately decays a number of times. Okay, we will end it there, and we will start up tomorrow with this Chapter 15, Cosmic Ray Decay. Have a great day.